Again, repeating what I just said. First equation has A and VI, but it doesn't have delta S or VF, right? I mean, yeah. So it's got two things that aren't here. So we can't use it to solve for anything. This one is also missing two things. And it happens that the two things that this thing is missing, actually what I said was wrong. There are three things missing between these equations. So anyhow, ignore what I said a minute ago. I didn't say it in tape, so it never happened. Okay, so if we go here, what do we got? We got VI, we've got A and delta. Oh, look at that. We got three of them, right? So we can use this equation. And from this equation we get VF, right? Now, we could also use this equation, which has VI, delta S, and A, and solve it for delta T, right? We don't want to do that if we can help it, because it's quadratic in delta T. When you solve a quadratic, you get two solutions, and you got to figure out which one works, which is usually pretty easy, and sometimes you're stuck having to do it. Right now, we're not going to worry about it. So I will say avoid using this equation to solve for delta T, okay? Even though you could do it, and you would do it based on initial information, right? But in this case, solving for delta T is confusing enough that we're just going to use the VF that we get from this equation and use this one. It's very easy, right? So this equation just says average your final and initial velocities. That gives you your average velocity. If you have a straight line velocity versus time graph, the average is right there in the midpoint, right? And we've got to understand that. Okay? And so we can use that with VI and the delta S to get the delta T, right? And that's your strategy if you're going to use these equations. Now remember, you don't deserve to use these equations unless you can derive them from the picture or from the calculus. That's not going to stop you from using them, but remember, you should feel a little guilty if you use them and don't know where they come from, especially since I might ask you where they come from on a test, right?
Where does the circled one come from?
Second one?
The circled one.
Huh?
The third one.
It comes from eliminating delta T between these two equations, as we did last time. And this one comes from eliminating another variable that I'll let you figure out from the first two. So what I'm saying is, and we've already done it, so I'm not going to do it again, you get these two equations, right? Then, treating them as simultaneous equations, you eliminate one variable at a time to get this and this. Now you've got four equations, each with four variables, and any combination of two out of the five variables appears in at least one of these equations, okay? And I'll also say it's never necessary to use this equation in this scheme to solve for delta T. It's not a bad exercise to go ahead and do it and convince yourself. Like, you could solve this problem, get your delta T, then you could take your initial information and put it into here and solve for delta T.
Couldn't we also use the formula on the top right on the top left, I'm sorry, to get delta T?
I'm sorry, once more, Alexander?
Couldn't we use the A equals